Somewhere in an archive sits a piece of paper with one word scrawled next to a string of numbers. Wow! It remains one of the most tantalizing, unexplained signals ever recorded, and scientists still cannot say for certain what caused it. On August 15, 1977, astronomer Jerry Eman was scanning printouts from a radio telescope in Ohio when he saw a burst of radio energy about 30 times stronger than the background noise, lasting exactly 72 seconds. It looked remarkably close to what researchers expected an artificial transmission to look like. Eman circled it in red and wrote that single word beside it. Nearly 50 years later, it has never repeated and has never been fully explained. But that raises a harder question. What would actually count as proof? Scientists generally look for two kinds of clues.
Biosignatures are signs of life itself, such as gases or chemical imbalances that biology might produce. Technosignatures are signs of technology, a radio signal, a laser pulse, or a structure too precise to look natural. Neither is a photograph of a spaceship.
Both kinds of evidence demand the same first step: rule out every natural explanation, which is harder than it sounds. That is why so many alien discoveries disappear after the first headline. SETI, the search for extraterrestrial intelligence, has spent decades pointing radio telescopes at the sky and listening, not for spaceships. For patterns, signals too narrow, too regular, or too unusual to be easily explained by a star or a cloud of gas. Telescopes such as the Allen Array in California and Green Bank in West Virginia scan millions of frequencies. Yet, after more than 60 years and thousands of stars, the 1977 WOW signal is still the famous case that refuses to fit neatly into a box.
Most other candidates turned out to be us, or nature. And this has happened before. In 1967, graduate student Jocelyn Bell Burnell found a radio signal pulsing every 1.3 seconds with the precision of a clock. It was so regular that her team jokingly called it LGM-1, Little Green Men.
For a short time, that signal looked like a serious alien candidate. Then, a second source appeared, and a third. Astronomers eventually realized they had discovered something just as remarkable, but entirely natural: pulsars. The rapidly spinning cores of collapsed stars, sweeping beams of radiation through space like cosmic lighthouses. The lesson stayed with astronomy. The universe is very good at faking the thing we hope to find. And that makes the larger silence stranger. Our galaxy alone may contain hundreds of billions of stars, many with planets, and it has existed for more than 10 billion years. Statistically, intelligent life should have had many chances to appear and perhaps spread. In 1950, physicist Enrico Fermi asked the question that still haunts the field. If the universe is so vast and so old, where is everyone? No confirmed signals, no probes, no visitors, just silence. Scientists call this the Fermi paradox. A few years later, astronomer Frank Drake tried to turn that question into something calculable. The Drake equation sounds intimidating, but the idea behind it is simple. The Drake equation multiplies a chain of uncertain numbers. How many stars form? How many have planets? How many worlds could support life? How often life begins? And how long a technological civilization remains detectable? Optimistic values fill the galaxy with neighbors. Cautious ones can leave us almost alone. The problem is that we still do not know most of those numbers. In 2020, a major biosignature story came from Venus. Astronomers reported phosphine in its clouds, a molecule that on Earth is strongly associated with life or industry. Venus is hellishly hot at the surface, but some high cloud layers are far milder, so headlines quickly asked whether we had found life in an alien atmosphere. Other teams reanalyzed the data and could not clearly confirm the signal. The debate remains unresolved, a good example of science working in public. If this kind of real mystery is your thing, like the video and subscribe. It helps us keep bringing you strange stories grounded in evidence. Venus is not the only chemical mystery. Since 2012, NASA's Curiosity rover has also detected methane in Martian air. On Earth, much methane is linked to life, bacteria, decay, digestion. On Mars, methane sometimes rises suddenly and then fades without a fully explained pattern. It could be geology. It could be ancient methane trapped in ice and slowly leaking out. Or, just possibly, something alive below the surface, producing it in a way we do not yet understand. Nobody knows, and that is exactly why Curiosity keeps watching. If life exists elsewhere in our solar system, many scientists now look beyond Mars and toward ice. Europa, a moon of Jupiter, hides a liquid ocean beneath a frozen shell, possibly containing more water than all of Earth's oceans combined. Jupiter's gravity provides internal heating, and Europa may have chemistry suitable for life. NASA's Europa Clipper, launched in 2024, is on its way to study that hidden ocean without landing. Answers will take time, but we are finally going to look closely. Europa is not alone. Around Saturn, the smaller moon Enceladus does something even more dramatic. It sprays its ocean into space. Geysers of water and ice erupt from cracks near the South Pole, carrying material from a buried sea. In 2005, NASA's Cassini spacecraft flew through one of Enceladus's plumes and sampled it. Inside were salt, water, and organic molecules, basic ingredients associated with life as we know it. That is not proof that anything is alive there, but it means scientists can sample material from the hidden ocean without drilling through kilometers of ice. Sometimes, the mystery does not come from a moon or a laboratory. It simply passes through the solar system. In 2017, astronomers spotted an object unlike anything cataloged before. Elongated, tumbling, and moving too fast to have originated nearby. They named it Oumuamua, Hawaiian for a scout or messenger from afar. As it left the sun, it accelerated slightly in a way gravity alone did not fully explain. Most astronomers favor an unusual natural object, perhaps icy material releasing gas as it warmed. One prominent physicist publicly suggested another possibility, that it might have been artificial. We may never know. Oumuamua is gone and is not coming back. Meanwhile, the James Webb Space Telescope can search much farther away, reading the chemistry of distant planetary atmospheres from light years away. When starlight passes through an exoplanet's atmosphere, different gases absorb different wavelengths, leaving a chemical signature that the James Webb Space Telescope can read. Oxygen, methane, water vapor. In the right combination, on the right world, such a pattern could become some of the strongest biosignature evidence we have ever seen, without sending a spacecraft there. But notice the pattern running through every story in this episode. Strange signal, rising excitement, then a more ordinary explanation. That is not science failing. It is science doing its job. Extraordinary claims demand extraordinary evidence, and aliens remains the least likely explanation until the alternatives are exhausted. Rocks that look engineered are usually natural.
Signals that look designed often have natural or human sources. The universe is enormous, strange, and very good at creating things that briefly resemble what we are searching for. So what would finally convince scientists? Not one signal, but a repeated one, confirmed by independent telescopes. Not one gas, but a combination that geology, chemistry, and contamination cannot explain. Not one photograph, but a pattern that survives every serious attempt to disprove it. The standard is deliberately brutal because it has to survive our own wishful thinking. Every almost in this episode, the WOW signal, phosphine on Venus, methane on Mars, the interstellar visitor, failed to clear that bar completely. That does not mean the search is over. It means the evidence has not reached the threshold yet. Maybe we really are alone. Or maybe the clue is already out there, in Venus's clouds, beneath Europa's ice, inside Enceladus's plumes, or in a signal we have not aimed the right telescope at yet. Every story here was rooted in real observations, and each still contains some uncertainty. That is not a disappointing ending. It is the most honest ending science can give us. Unlikely does not mean impossible. It means we have to look carefully enough to tell the difference. If you want another story where the real world turns out stranger than it first appears, there is more waiting for you here. Subscribe and join us for the next episode.